Hey all, as soon as I get a couple of people actually in the chat, I will Hey folks, please let me know if you can hear me and how the sound is. I can see I could probably turn my mic up just a little. Okay, let's try a little more mic. Ooh, that's just a little too much, but how's that? Okay, let's try a little more microphone. And how are people tonight? Today, for those of you in the United States, oh, good, good, good. Okay, great. Fantastic. I'm glad that everybody's up and raring to go. I've got something a little different than the usual I will blather and you will listen and get bored thing. Yay. That's great. Yes, it's May Day. So, happy May Day to everybody. And this evening, what I want to do is to do something a little different. I'm going to many of you are struggling with finding how to think in Prolog, so I thought I would take live problems that you throw at me and work them kind of live and in person. So if you want to take a moment and throw me and locate some Prolog problems, please nothing that's been assigned as a class problem, but I know a lot of you were doing other problems on the side, and if somebody will pick a problem that they found interesting or difficult, or maybe just would like to see me work, I'll give it my best shot. And I will talk along and tell you what my thinking process is. Warts and all. Okay? So there will be a moment of slurping while I drink my drink and wait for you to come up with problems. And just kind of waiting for somebody to throw me a problem. I see Patrick starting to type. Um, let's see. Well, Einstein's riddle, I was a homework problem. I don't want to. I don't want to work that one. Dijkstra's algorithm, the evolutionary algorithm thingies on Rosetta code. Okay, Dijkstra's algorithm is a search algorithm. I have to confess, that's likely to take that's likely to just take longer to code up than will work for this format. The Dijkstra's algorithm. Okay, I'm going to parsing strings into atoms until somebody tosses me traveling salesman. Okay. Yeah, to do traveling salesman, of course, that's NP complete. And you know, doing a dynamic programming solution is probably outside the scope of this. I'm going to start by talking about Patrick's thing of doing strings into atoms and back and forth. Okay, Patrick. So strings are yeah, sure, I can work one of the EU problems, but hang on, I'm going to get the tell you what, if nobody's coming up with a problem, I'm going to just pick one. All right, I tell you what, so how about if I do something with DCGs? All right, I'm going to do something with DCGs. How about if I convert infix notation to prefix notation using definite clause grammars? Okay, let's see. I will. Yeah, we're coming up on them. And so I'm going to do, and I already, okay. How to convert statements to predicates. Yeah, I'm going to do Chandra's thing first. Okay. No dragon who lives in a zoo is happy. Okay. No, hang on, I gotta make that bigger or you'll never see it. And for some reason that always increases the size, which is a silly thing to do, but it's what it does. Okay, no dragon. Is that big enough? Okay. No dragon who lives in a zoo is happy. All right. And how would we make this sound more Prolog-y? Well, I usually start by making it sound a little bit more like it's quantified, which is this thing of if x is a for all x, if x is a dragon and x lives in a zoo, then X is let's see here. We can say then X is not happy by the contrapositive. Okay. All right. The rest of it, let's write the rest of it out. Okay. Any animal who meets kind people is happy. Right, and of course, Chandra, this is going to be opposite conclusions. So, we're going to have two different conclusions here. So, happy, and we're going to have to disambiguate those just with the file order, and we may have so then we're going to have be able to ask some question: is X happy? And we'll figure out if X is a dragon, and X lives in the zoo, then we conclude that X is not happy. Okay? I think this is what you're driving at with your question. X is happy. We have a different rule. That's going to be X is happy if X is an animal and meets and X meets some person Y. Should we use fail or false? Normally we would use fail. The two are actually defined as synonyms in Prolog, and sometimes it makes more sense to use it can make things make more sense if it says false. But here I think we want to say cut and then fail. The reason I'm using a cut is that I'm saying if they're a dragon who lives in a zoo, they are unhappy, which your ambiguity is in the English. That is okay. It would help if. All right. I am going to copy the entire statement again because somebody asked me to, and all right. Okay. All right. So, any animal who meets kind people is happy. If X is an animal, X meets Y, and let's see, line by line mapping from English to predicates, okay. All right, well, I've done that one. Now, okay. Any animal who meets kind people is happy. Great. Okay. Now, by the way, we should define some of these. Still need to say that it's a person they meet. If yes, you might need to. Well, there is a contradiction, and I think Chandra has been bugging me all along for how do I deal with contradictions. So this is fine. You are going to run into these kinds of situations, and yeah, are dragons considered an animal? I suspect they are for this. Let's make Puff a dragon. Puff lived in Honolulu, if I remember my childhood song correctly. No dragon lives in a zoo. Okay. Well, if no dragon lives in a zoo, then tell you what, let's not put in that. And in a line, Puff the magic dragon lives by the sea and frolics in the ocean mist in a land called Honolulu. Right. Okay, well, Puff can live in Honolulu, but no dragon lives in a zoo. Great. Who's another dragon? Help me here, folks. My dragon foo is failing me. Somebody tell me the name of the dragon they steal the Smog. There we go. Okay. And I'm not going to say where Smog lives. I'm going to say lives in X zoo. Okay. And yeah, for example, one thing that we actually have to tell Prolog would be that if a dragon lives someplace, they don't live in another place. Dragons don't have vacation homes, summer homes. And Chandra is saying that no dragon lives in a zoo. But does that mean if a person lives in a zoo, if someone or something lives in a zoo, then that person, that is someone who is not a dragon? Or do we mean that if something is a dragon, it does not live in a zoo? Conclusing is not a word. Conclusion. There we go. Conclusion? Yeah. And in that case, I can just say false here. Now, what that really says is this rule proves nothing. Okay, the reason it proves nothing, if foo xy, then there's nothing else that can satisfy a little blank. Yeah. So Patrick's statement is again just saying false. Patrick's statement is actually this one. Well, Patrick, your statement is, so nothing else. Nothing else. That would be, is zoo an atom? Zoo is an atom. Lives in is a predicate. No. Well, what does it would mean? What would it mean for zoo to be a predicate? Predicates are things that that you could prove, and I can't prove the zoo. Exclusivity is usually with a cut. So for example, like Dragon X. Dragon X means is a dragon. This is a better name for this because it's the predicate. Is this thing a dragon? Puff is a dragon. Zoo. Yes. Zoo of X would be like, okay, so there could be an is zoo. All right. This could be is dragon then. Okay. So I'm getting a lot of stuff here. Okay, let's back up here, and I'm going to try and, okay, fine. Rather than just lives in an arbitrary zoo, I'm going to say lives in a location, and then is zoo location, okay? And I am going to have is dragon, we need another dragon. I have a plushy dragon I call Smog. I may regret that with the homonym with Smog, but I will try and keep them clear. But lives in Smog. Let's have Smog live in the Bronx Zoo. So we have a dragon who lives in a zoo. Spyro. All right, let's use Spyro. And Spyro is going to live in the Bronx Zoo. If Spyro lives in the Bronx Zoo, then is zoo, the Bronx Zoo. Okay, it's a zoo. So, all right, an animal who meets kind people is happy. You keep tossing out suggestions here, and happy, and then people who visit zoos are kind. All right, so kind is kind. By the way, a lot of times people do omit the is, so is kind. Let's make Bob be a person who is kind and visits zoos. And, oh, okay. Hold on, we don't actually need that. We need we need to know this is, of course, is an animal. X is an animal. Well, the only kind of animals we're dealing with at the moment are dragons. So one rule is if they're a dragon, dragons are animals. And people who visit zoos are kind. Any animal. Okay. Now, you know, this is going to get a little crazy because now we have to explain to it that if a person visits a place that a person lives, that person will meet the other person. You might, so now this gets kind of messy, right? Is kind, X, and then people who visit zoos are kind. Is kind X, visits zoo X. Okay, and if you meet an animal who lives somewhere, then you have visited there. Okay, and so people who visit the zoos are kind. Okay. And then animals who live in zoos meet the people who visit zoos. Yes, that's the last one we need. Okay. So meets X, Y is, this is actually, there's some more, lives in a location and that's X, the zoo, a location, and that location is, if they visit that location and that location is a zoo. Okay, so back up, now we can come back up here and say meets and visits, then Y visits that location, then they meet. There's another way to meet, and that would be 4. Them to be the reverse. Okay. Please cut and paste the English statement. Okay. That one? Or this one? I'm going to cut them both. All right. Okay. All right. Any animal who meets kind people is happy. People who visit zoos are kind. Okay. People who visit zoos are kind. And I was more general here. Yeah, Chandra, the problem is I'm using this large font and only have enough. I don't have that much space, so when you ask me to do that, you're burning my space up. But okay, and then other things could visit the zoo, right? Local birds could visit the zoo. So we need a random person so that there is at least one person around. And let's make Bob someone who visits the zoo. The Bronx Zoo. Bob has to visit some zoo. And then this is a zoo. Okay. All right. Is kind, doesn't have. It says people, right? So I guess they have to be a person. I will add that. You can see that there's an awful lot of sort of cetera, what they call ceteris paribus, all other things being equal, involved in reasoning. Things like having to explicitly say that if A visits a place and B lives in that place, A will meet B. So this kind of reasoning can become messy. Okay, and then, who can we conclude is happy? We can conclude no one is happy from this. Prolog is closed world. If we can't prove it, it's not true. And of course, what's going to happen here is that the dragons who live in the zoo are not going to be happy. But the only way to meet, to be in the last one, is to meet a kind person. Okay. All right. So I'm not certain where we're going with this. Prolog is not a general purpose engine for performing logic. Prolog is an SLD resolver. We are guaranteed that the first happy clause gets executed first. Yes, Prolog will guarantee that. It is the S in selective. And no, we never evaluate the second clause because of the cut. When you encounter a cut, you're going to do a couple things. If any of these things left you a choice point, any of this stuff, then that choice point will be erased. Furthermore, whatever clause I'm in, like this clause of happy, I will only use that clause for happy. I will not use any other clauses. So I erase all choice points since we entered the predicate. And entering this predicate generates a choice point because there's two clauses. Okay. And all right. I see more questions, so I'm stopping. Yeah, the cut erases the usage of the other clauses on this particular okay. What happens if we change the order of the clauses? Well, now, and then my comments aren't keeping up here. I'm going to blow away this comment because it's becoming counterproductive. And of course now, Spyro's happy. Spyro's happy because Spyro lives at the Bronx Zoo, and there he meets Bob. Bob is a kind person who visits the zoo. Now, if I remove the cut here, then if I remove the cut, then what would have happened in the old order? If I go back to this, and I remove the cut, then what's going to happen is that it will find Spyro. Here's what it's doing. It tries to find out if Spyro is happy by this rule, and that doesn't make Spyro happy. But so it tries the second rule, and the second rule says Spyro is happy. Okay. So cut is intended to say, and I have found the only case that matters. It prunes away our choices. How do we know the order in which we have to define the clauses? Your initial problem specification contains a contradiction. And all you can do is to figure out which rule takes precedence. hit or trial. It's the order, well, the order in which you read the problem statement may give you a clue, but the problem is, the problem with your problem statement, I mean, just because you can write it out in something that sounds like a logic problem doesn't mean it's going to be clear and unambiguous. And here you have given me two rules, one of which you've given me two rules which might contradict. Prolog resolves these contradictions by having an order. So you have to decide which rule comes first, particularly if you put a cut in there. Because that cut is going to say, and no other. Forsaking all others, say in the marriage ceremony. Are we missing that there are other animals? No, we can, put in yes. Yes, and if there are other animals, then I guess they can be true. So, okay. Animal X let's add a pig. Okay, there's Porky. Porky is a pig. And now let's find out who's happy. Are we back with our original version? Yes, we are. Whoop, nobody's happy now. What happened? Let's see here. No. My problem is that it has said, okay, well, what I really want to do is say X is a dragon that lives in and is in a zoo. Then yeah, it's because of the cut that this is not working properly, and I'm trying to think how to get out of it. X is a dragon. That lives in a zoo. X is an animal. Who meets a kind person. Now, if I simply do this, I'm going to include Spyro. Why do we evaluate the cut for Porky? Right, that's... so, what I really want is... is that I want... should fail before the cut is dragon. Yeah, is dragon. Let's see, is dragon. Well, it is going to fail. What am I not thinking of? You've managed to flummox me. Okay, let's think about this. Well, is dragon's not going to fail before the cut because X could be anything at that point. And the problem is that we're saying, no, no one is happy if there is a dragon living in a zoo. That's our problem. This clause is incorrect. It's saying if X is a dragon who is living in a zoo, can I rerun the predicate? It fails. And the reason it fails, no, Chandra, it's definitely not run before that. The problem is this, is that the first statement says, is X happy? Well, they were looking for a value of X that makes it happy. The problem is that we've said X is a dragon, X lives in the zoo. Okay, then that is then that is not someone who's happy. So there's another way to do this, and that is X is an animal. What we really need is a more complicated rule, and that is X is an animal, and then X is not okay. By the way, I'm hitting Alt/, which will automatically complete. And I managed to type the wrong thing there. Okay. Yeah, we declare that Bob. We declare that people meet people who live in a location if they visit that location. Okay. So that's not our problem. Our problem is that we're trying to resolve happy and unhappy, and this is just going to look a little messy because when you have this mix of things that cause happiness and things that cause unhappiness, and then you're going to have to decide which one or what that rule is for resolving those, which is, I think, Chandra's initial problem here. Okay, and we're still not getting, why are we not getting it now? Okay, and now that's not what I expected to get. So let's find out what's going on. And sorry, I'm not certain. Let me see if I can find out. Nope, I cannot. I cannot make that bigger, unfortunately. Okay, so I don't know what's coming in small, but so happy so if it's happy, if it's an animal, Puff is not unhappy living here, but doesn't meet anyone. There's Smog. There's Spyro. Okay, Spyro is unhappy living here. There's Porky, who is not unhappy living here. but does not meet, does x meet y? The problem is that we haven't instantiated y. So, let's try revisiting that. X meets y. Well, this is Porky. Did we say that Porky lives in the zoo? We didn't say that Porky lives in the zoo. So we're going to hit abort. And, okay. So I'm also going to have Porky live in the Porky lives in the Bronx Zoo. That was my problem. Okay. And now we get Porky. And I fumble finger things and get the old debugger, but otherwise, okay. And, all right. And, okay, that was that one. I think we've kind of run this to the ground. We've used up most of our hour on it. So what I did earlier, these problems of contradictory rules of positives and negatives, you kind of need to be, we do still need unhappy living here, yeah. These rules of positives and negatives, we have to have unhappy living here because we must have that the animal is never happy, even if it meets kind people, if it's unhappy where it lives. Does that make sense? And again, just because something sounds like it's stated logically, won't happy with a cut suffice. No, it won't. The problem is that that when x is unbound, we're actually asking, is anyone happy? And then we get proof by construction, and the problem is that as soon as we discover that there is a dragon who is unhappy with its living location, that we cut. And we're cutting too far. We're cutting all animals. We could have made, some happy dragon and then happy other animal cases in happy. Okay, great. All right, but the real thing is that we need, basically you got a Venn diagram here going, and you need to figure out which cases go where. So, so these problems of positives and negatives can get complicated. I like the unhappy style. Okay. All right. All right. We have used up the hour, I'm afraid. So I think at this point there's little point in starting another problem. So I will let you all go. I think these are productive. I may actually, in this coming week, I may just do some live stream of myself coding on something, and people can pop in and out as they feel that's useful. Okay, I think you're all progressing really nicely. Yay! Thanks, everybody. This was a good little problem to work. All right. Okay. I'll see ya. You know, I'm going to close this with a quote by Richard O'Keefe, who wrote The Craft of Prolog. Great book. If you should get a copy of it. And that, and he says, you haven't a chance of writing the program if you don't understand the problem you're solving. Yeah. Good. Okay. All right. I will see you back on Slack, folks. Bye.